Welcome to the Nokia SR Linux Learning Essentials video series, brought to you by the Nokia Data Center Fabric Certification Program. This video explains how to configure external or eBGP as the underlay routing protocol on the SR Linux router. While ISIS and OSPF can be used as the underlay routing protocol, BGP has become the protocol of choice for the underlay of modern leaf and spine data centers. BGP utilizes routing policies to control the flow of network updates into and out of a router. BGP is the routing protocol of the Internet, and with multi-protocol extensions, BGP can be used for many different applications such as multicast, IPv6, Layer 2 and Layer 3 VPNs. Our lab topology consists of a leaf and spine data center, with 2 leaf routers connected to 2 spine routers. External BGP or eBGP is used as the routing protocol for the underlay. Each leaf router is in its own autonomous system or AS, while all the spine routers belong to a single AS. We are going to configure 2 eBGP sessions on the SR Linux router leaf 1. One session to spine 1 and one session to spine 2. Router spine 1 and spine 2 have been pre-configured with eBGP sessions towards leaf 1. First, we are going to navigate to the network instance default. We are looking for 3 interfaces, 2 physical interfaces, one to spine 1 and one to spine 2, and a single loopback interface whose IP address we'll use for the router ID. We want to verify that the required interfaces are in the network instance default and are operationally up. Now that we have verified the interfaces, we'll enter the candidate mode and start configuring the routing protocol BGP. Enable the BGP protocol. Assign an AS number to the router. In the diagram, leaf 1 is in AS 65001. Assign a router ID. In this case, we use the IP address of the loopback interface. Assign and enable the address family to be supported by BGP. Create a group and assign it a name. In this instance, we'll call it spine. In the group, we define the AS number we expect the spine routers to be in, which is 64,999. Finally, we create our neighbors using the physical interface IP address of the spine routers and assign them to the group spine. We add the interface towards spine 1, and then we add the interface towards spine 2. We will use the info command to check our configuration. Once we are happy with the configuration, we will use commit stay to commit the configuration and stay in the BGP context. Now we can check our BGP neighbors. We see that leaf 1 has established BGP sessions to spine 1 and spine 2. We also see that leaf 1 is receiving updates from spine 1 and spine 2, but it is rejecting them. As well, leaf 1 is not sending any updates to the spine routers. It is the default behavior of eBGP to reject all received updates and not to send any updates to its peers. When we look at the routes being received by leaf 1 from spine 1, we see the local network that connects leaf 1 to spine 1, the network that connects spine 1 to leaf 2, and the IP address of spine 1's loopback interface. We see that these networks have no status associated with them as they are being rejected. We can modify the default behavior of eBGP by creating and applying import and export routing policies. However, that is a topic for another video session. Today, we'll simply modify the eBGP default import policy behavior to allow Leaf 1 to accept the updates from the spine routers. We'll look at the routes that Leaf 1 is receiving from spine 1 again. Now the routes have some status associated to them. All 3 routes are considered valid, but only 2 of the routes are the best and used. Those 2 routes will appear in the route table of network instance default. The one route that is not used is because that prefix is a local prefix on Leaf 1. That's it for SR Linux eBGP for the underlay. Thanks for watching, and be sure to explore the rest of this video series to learn more. And when you're ready to practice what you've learned, my DCF Learning Labs provides comprehensive exercises with step-by-step instructions and solutions, all in one simple browser-based application.